Dimensional analysis. So dimensional analysis is a really useful way of solving problems that we use a lot in chemistry. It takes advantage of the fact that anything divided by itself is equal to 1. So 30 divided by 30 is 1. 3 billion divided by 3 billion is 1. X divided by X is 1. So we use units and cancel them out by dividing them. So see how I have 6 bananas over 1? And then next to that, on bottom, I have bananas. So what I'm doing here is I'm dividing bananas by bananas, and so that unit cancels out to 1. Next, oranges will cancel oranges here. So the only unit that hasn't been canceled out is strawberries, and that tells us the units that our answer will have. So in order to solve this, I would need to do 6 times 2 times 15, get that answer, and then divide that by 3. So that would give me 60 strawberries here. So that first example was kind of a goofy example, but in the next example, you can see how this information can be used. So let's say that I want to figure out how many meters are in 30 inches. So if I know how many inches are in a meter, then I can do this really quick. But what if I don't know that conversion factor? What if I know that 1 foot is 12 inches and there's 3 feet in a yard, and I know that a yard is just shy of a meter? So here, inches would cancel inches, feet cancels feet, yard cancels yard, and so the only unit left is meters, which means that my answer is going to be in meters. So I would need to do 30 times 0.9144 and divide that by 12 times 3, which is 36. So let's think about this problem here and try to use dimensional analysis. So we want to know how many seconds are in 2.3 years. So let's think about this. If anybody knows how many seconds are in a year off the top of their head, then they could probably just do this in one step. But I don't know that off the top of my head. So I do know how to convert years into days, and I do know how to convert days into hours, and hours into minutes, and then into seconds. So this is going to be our plan here. We're going to change the units of years into seconds. And we're going to multiply across and get the number of seconds that are in 2.3 years. So first thing I want to do is take what I am given in the problem and put it over 1. So since the problem gives me 2.3 years, I'm going to put that over 1. Now, it's really important that you include the units on all of your numbers here, because that's how you know what to multiply and what to divide in order to get this answer. So I know that I want to cancel out years. So I'm going to put year on bottom here. And according to the plan that we just wrote in question 2, I want to convert years into days. So I'm going to go ahead and put units of days on top here. Now, if we filled in some numbers and solved right now, that would just tell us the number of days in 2.3 years. So we're not done. We need to keep going. So now I know that I want to change days into hours. So now if I stopped and solved, my answer would be in hours. So we're not done. We got to keep going. So I can change hours into minutes, and then I can change minutes into seconds. So now that we have this all set up, we need to plug in our conversion factors. So this is going to be a quality statement here. So how many days are in a year? Well, we can say that 365 days is 1 year. My next conversion factor is how many hours are in a day. And we know that there's 24 hours in a day. Next, we're looking for a conversion factor between minutes and hours. So do you know that conversion factor? We know that 60 minutes is equal to 1 hour. And then the last one, we're looking at how many seconds are in a minute, which is also 60. So in order to solve this, we would take all of my numerator, multiply that together, and then divide by the denominator here after we multiply it all together. So in this case, everything on bottom was a 1. That's not always going to be the case, but in this case it was. So here's the answer that we get. You have a couple more practice problems to try. So go ahead and pause the video and try the next couple of questions. And when you're ready, return here to check your work. Okay, so in question 4, we want to convert from 1.23 liters into milliliters. So first thing I'm going to do is take my given and put that over 1. So there's 1.23 liters is what we were given. That is what we're going to start with. Now in my next step, I need to think about the different units that I need to convert between to get from liters to milliliters. Well, liter and milliliter, we can go from one to the other just by using our metric prefixes here. So milli means 1,000 times smaller, meaning that there are 1,000 milliliters in 1 liter. So I'm going to fill in that conversion factor. See how 1,000 is with milliliters? Keep it with milliliters. It wouldn't make sense to say that there's 1,000 liters in 1 milliliter. That's the wrong relationship. So in order to solve this, I need to do 1.23 times 1,000. So my answer here is 1,230 milliliters. The next question, we want to convert 56 millimeter into centimeter. So if we know how many millimeters are in a centimeter, we can do this in one step. If we don't know that, well, we can change millimeter to meter and then meter to centimeter. So I'm going to start with my 56.0 millimeters over 1. And I'm going to change millimeter to meter. Then I don't want meters, I want centimeters. So I'll change meters to centimeters. So we can solve this just by knowing our metric prefixes here. So milli means 1,000 times smaller. So there are 1,000 millimeters in 1 meter. Centi means 100 times smaller. Like a century means 100 years. So 1 meter then is 100 centimeters. So when I solve this, my answer here is going to be 5.6 centimeters. Now I mentioned if you knew that there was 10 millimeters per centimeter, then you could have done this just in one step. If you didn't know that, you would have to do 2 steps. But either way here, mathematically, we end up with the same answer. And that's because 100 over 1,000 is just 1 over 10. Okay, so pause the video and take the next couple of minutes to try these 2 questions. Number 7 is a little bit of a tricky one. Notice that the units are miles per hour. So I want you to think about how you would write that as a fraction whenever you go to solve this. Go ahead and pause the video, take some time to try, and come back here whenever you're ready to check your work. So, number 6, we want to figure out how many miles are in 200 centimeters. So I'm going to start with my given, and that's the 200 centimeters over 1. Now looking at my conversion factor here, I don't know how many centimeters are in a mile, But I do know that 1 inch is 2.54 centimeters. I know that there's 12 inches in a foot, and I know that there's 5,280 feet in a mile. So we're going to first take centimeters, and we want to convert this into inches. Then I can convert inches into feet. So I'm dividing by inch to cancel that out, and on top, I'm multiplying by foot. And then lastly, we want to convert feet into miles. So everything's going to cancel out here. That's what's nice about these kinds of problems, is that you can always know if your units are going to come out right, and that's a good way to check your work. So I'm going to fill in these conversion factors. 1 inch is 2.54 centimeters. Notice that 1 stays with inch and 2.54 stays with centimeters. We know that 1 foot is 12 inches. 1 mile is 5,280 feet. So mathematically, we're going to have 200 times 1 times 1 times 1 on top, and then we have our denominator here. So it's not always going to be a 1 on the bottom. It kind of depends on which direction you're converting in. So when we do all this math, here's what we get. Now this number is pretty small, so when we have small numbers, we like to express that in scientific notation. So in scientific notation, it would be 1.2 times 10 to the minus 3. Okay, question 7. You are traveling in a car at 50 miles per hour. How many feet per second is this? Okay, so this one's a little bit different from the other ones in that we have 50 miles per hour. So look at how I'm going to write this. I've got 50 miles per, with a division line, 1 hour. So this is one of those cases where you don't just have a 1 on bottom. You also have a unit on bottom. It's miles per hour. So miles on top, hours on bottom. So we got 2 things we need to do here. We need to change miles into feet, and we need to change hours into seconds. So first thing I'm going to handle, I'm going to convert mile into feet. That's easy. We already know that 1 mile is 5,280 feet. So if we solved right now, my units would be feet per hour. Miles would have been canceled out. So that gets me close. That gets me to feet per hour. I want feet per second. So now I need to deal with this unit of hour here. Now, in this case, hour is in the denominator. So to cancel out, hour needs to be in the numerator here. If you know how many seconds are in an hour, you can do this in one step. If you don't, you change hours to minutes, minutes to seconds. Notice that we put minute on top this time so that it would cancel out the minute that's on bottom in the term below. So I'm going to go ahead and fill in some numbers here. We know that 1 hour is 60 minutes and 1 minute is 60 seconds. And so the only units that haven't canceled are feet and seconds. So my answer here is going to be in feet per second.